So, good day to all of you. So, in this session 9, we have to describe today about the smoothing process in the natural language processing. So, basically, what is a smoothing in the NLP? So, smoothing refers to the technique we use to adjust the probabilities. Okay, so used in the model so that our model can perform more accurately and even handle the words absent in the training data set. If it in the training data set it is absent, the words are absent, so smoothing technique it will be it will that the technique to handle the words, the absent words in the training sets. So that is about the smoothing, we can tell. And what do we do with words that are in our vocabulary? There are not unknown words, but appear in a test set in an unseen context. So, to keep a language model from assigning zero probability to these unseen events, we will have to save off a bit of probability mass from some more frequent events and give it to the event we have never seen. This modification is called smoothing or discounting. Okay, then what do we need smoothing in NLP? Basically, to improve the accuracy of our model, we have to use the smoothing, and to handle the data sparsity, our vocabulary words and words that are absent in the training set. So we can use the smoothing process in the NLP for that reason. And what are the different types of smoothing? So basically lot of smoothing algorithms are there, but basically we take these four algorithms which are more important in the smoothing process. So one is the Laplace, that is odd one smoothing, we can tell us, and odd k smoothing, second one is, third one is stupid backup smoothing, and fourth is Niger-Ney smoothing. So we have to discuss to one by one the what is Laplace and what is RK smoothing, what is stupid backup, and Niger-Ney smoothing. So what is Laplace smoothing? The simplest way to do something is to add 1 to all the bigram counts before we normalized them into probabilities. And all the counts that are used to be 0 will now have a count of 1. The count of 1 will be 2 and so on. So it will be added one by one, it will be added one by one. So this algorithm is called as the Laplace smoothing. Okay. So let's start with the application of Laplace smoothing. So unigram probability we will take if the word Wi is its count Ci normalized by the total number of word tokens n. So what will be the probability here? So probability of word count Wi is equal to Ci divided by n. So Laplace smoothing merely adds 1 to each count, hence it is alternate name odd one smoothing. Since there are V words in the vocabulary and each one was incremented, we also need to adjust the denominator to take into account the extra V observations. So the formula it will be P Laplace of Wi equal to Ci plus 1 divided by n plus V. Okay, then instead of changing both the numerator and denominator, it is convenient to describe how a smoothing algorithm affects the numerator. So by defining the adjusted count C star, so the C star here value it will be C star that is Ci star equal to that is Ci plus 1 divided by n that is n divided by n plus b. So we cannot turn Ci star into probability Pi star by normalizing the n value, that is MLE count, by normalizing the value. Then a related way to view smoothing is discounting, that is lowering some non-zero count in order to get the probability mass that will be assigned to the zero counts. Thus instead of referring to the discounted count C star, we might describe a smoothing algorithm in terms of relative discount DC, the ratio of the discounted count to the original count it will be. So DC equal to C star by C, the value it will be. So Laplace smoothing, these are some the unigram case, that is Becquerel's restaurant project diagram. So it was given by I want to eat Chinese food lunch spend. Okay, so here it will be added one by one, we can see in the table. So I want to eat Chinese food in the lunch spend. Okay, so add one smoothing, that is called as the Laplace smoothing here. So normal bigram probability are computed by normalizing each row of count by the unigram count. Okay, so what will the final Laplace probability it will be here? Wn, that is over Wn minus 1, equal to, that is C of Wn minus 1 Wn plus 1 divided by summation of W C into Wn minus 1 W plus 1. So the resulted value it will be Cwn minus 1 into Wn plus 1 divided by Cwn minus 1 plus V. Okay. So again we go for the odd case smoothing. So one alternative to odd one smoothing is to move a bit less of probability mass from the seen to the unseen events. Instead of adding 1 to each count, we add a fractional count k, that is 0.5, that is 0.05, or it may be 0.01. So this algorithm is therefore called odd case smoothing. So for probability of odd k, that is Wn over Wn minus 1, the formula it will be calculated like that: C of Wn minus 1 into Wn plus k divided by C into Wn minus 1 plus kV, that is odd case smoothing. Back of an interpolation or the technique also there. So that involves using lower level model when a higher level model cannot provide an accurate prediction. For example, if a trigram, we will take a trigram language model cannot predict the next word in a sequence. So it can back up to the bigram language model, which only consider the previous two words. This process can continue until a unigram language model is used, which only considers the current word. So interpolation is a technique that involves combining the prediction of models to produce more accurate prediction. Okay, so this would allow the model to take advantage of the strength of each model while minimizing the weakness. That is the linear interpolation formula. So that is the probability of Wn over Wn minus 2 into Wn minus 1. So whole over here, that is the lambda 1 probability of Wn over Wn minus 2 and Wn minus 1 plus lambda 2. Likewise, it will be added up to lambda 3, such that the lambda sum to 1. The summation of lambda equal to 1 here. And next one is the Naser-Ney smoothing. So one of the most commonly used, best performing n-gram smoothing method is the interpolated Naser-Ney algorithm, which is developed by Naser and Ney in 1995, Chen and Goodman 1998. They have then developed that research that on Naser-Ney smoothing. So it is a technique for smoothing n-gram language model, and it is more sophisticated discounting scheme than absolute discounting, which is a simpler smoothing technique. And Naser-Ney smoothing takes into account the number of distinct words that precedes an n-gram in the training corpus. This allows Naser-Ney smoothing to better estimate the probability of unseen n-grams. So that is the Naser-Ney smoothing. Some bigram counts training sets are there, and bigram counts in the held out sets are also there. That is of the training set it will be 0 to 9, and the bigram count it will be counted as also, we can see. So that is the Naser-Ney smoothing. So in the summary you will go, in a language model we use parameter estimation, that is MLE, on training data. We cannot actually evaluate our MLE model on unseen test data because both are likely to contain words in grams that the models assign 0 probability to. So relative frequency estimation assigns all probability mass to event in the training corpus, but we need to reserve some probability mass to events that don't occur, unseen events in the training data. So some self-assessment questions are also there. So which of the following smoothing technique assign too much probability to unseen events? Okay, so options are like they are R1 smoothing, RK smoothing, right belt smoothing also they are, good Turing smoothing also they are. So basically the answer it will be R1 smoothing. So in the second question, in RK smoothing method for a small k value, what would be the possibility? So it will be high possibility. So some of the terminal questions also there, like describe the Laplace smoothing, and second is the list out different types of smoothing techniques, and third is analyze the smoothing in n-gram model and summarize the purpose of the smoothing. So we have taken some reference for further learning of the sessions. So some reference books are also there in the smoothing tutorial, and the site and web links are also available. So thank you.